This is Dimitri French from Group 4, presenting Lab 2, Part 1. So here we have our original code here. Let's go ahead and start debugging and break. So the code starts, begins data segment at 0x100, and it allocates 1 byte of memory to the quotient remainder variables. Let's open our processor status here. So we keep an eye on our stack pointer as we go here. We're at 0x08ff, and it's going to start jumping up as we start calling more subroutines. So right now we're going to jump to main, and we're going to call our first subroutine init. So this is initializing variables subroutine, and once we step into it, you'll see the stack pointer change. So stack pointer has gone up, and we have our LDS count started. We're going to get our initial count here, and the stack pointer is going to stay the same as we run through this initialization subroutine. So now we're going to clear the quotient, remainder storage, and now we're going to call our second subroutine, get nums. Stack pointer went up again. So we're storing our dividend in register 30, and then our divisor register 31. And during this whole thing, the stack pointer is going to be the same until we call test. So test is going to check if the dividend is equal to 0. And if it is, it's going to continuously loop in test 1. If it's not, it's going to continue to test 2. And we'll see our stack pointer change again. So now we went up to F9 here. We got CPI register 30. This is where we're checking to see if it's if the dividend is equal to 0. And if not, we'll go to test 2. So here at test 2, we're storing that value, register 31, is divisor equal to 0. And if it is, then it loads a division by a 0 error, and the program halts. If not, then it continues test 4. Once again, you'll see that the stack pointer is the same for all these tests here. So register 3031 is dividend equal to the divisor. If yes, then it loads a value 1 into quotient. If no, it continues test 6. So we jump to test 6. Test 6 checks if dividend is less than the divisor. If it is, it continues to test 7, and it stops in a continuous loop. If not, it continues to test 8. Notice the stack pointer is still the same here. Okay, so now that we hit our, now that we call divide, our stack pointer changes again, it goes up. And we're actually going to be subtracting the divisor from the dividend. We keep subtracting until a negative number is reached. So we're going to keep doing that until the negative number is reached. Okay. And then we add a negative value from subtraction to divisor to get a remainder value. So the answer to the division operation is stored in the quotient. and the remainder of the division operation is stored in the remainder. So we have our R0 register here, where the division operation was stored in the quotient, and then down here we have our R30, where the remainder of the division operator was stored in the remainder. Here we return to main to halt program and jump in main loop. So here we're going to start returning. The stack pointer is going to start moving back up. As we move up the return functions. Okay, that's in main. That's all for part 1. Okay, so part 2 of lab 2, we're going to take some code for Celsius to Fahrenheit lookup table, and we're going to make some comments on it, rewrite the program, and sort the 20 random values from greatest to least. So here we've initialized some variables. You see that we have a pointer. We have 2 pointers, a z pointer and an x pointer. This is for comparing values, and for the output value here, we have our counters here. Register 10 and 17 will be counters for the transfer table loop and for loop 1, and 18 is used as a constant for incrementation and decrementation where needed as we're sorting these variables. And break loop 1 is going to branch loop 1 once the values have been transferred to SRAM. So let's go ahead and get into it. We're going to step into, and now that we're at transfer table, this is going to run 20 times, as it's going to take all of these values and it's going to store them here in SRAM. So after we stored all the values, it's going to run back through main and break to loop 1. So we reset our X memory location, and then we start. We reset both of our X memory locations, and we start comparing the values in the table. So it's going to be comparing a value to the one to its right. Okay, so we have a value that's out of order, and it branches to if less. So here you can see the value being changed, and then the one that was here is going to be there. This will now go to loop 2, where it's going to compare that value that was switched to the right to the next value, and then if it's greater, then we go back to loop 1. We start comparing the values again. So let's just go ahead and run through this quickly and let it sort all the values. 4D's got to go all the way up there. It's going to keep looping through, loop 2, and if less, until 4D goes all the way up to above 4.9, I believe. Yep. Move 17 up past 16. And that should be it. There we go. So now we have sorted values here. So for part 3 of lab 3, we were given this code that we then want to build the solution up here and go to the output files and go to the LSS file, which generates the machine code at the bottom here. I've already commented it all out. I left the original comments that were made once the solution was built, and these are my comments over here. So here, this loads the value of global C to register 25. In this line, we load the value of 2 to R24. Here, we perform an XOR bitwise operation, stored in register 24. Well, we're performing it between these two, but storing register 24. And then we're going to load the value of global B to register 25, perform a subtraction of the two registers, and then we're going to load R24 to global A in the SRAM, and then we're going to return.